Well, hi, good morning. Thank you so much for joining me in my shop here. It's April 13th, and the sun is shining, and it's above freezing, and spring is coming. Yes, it's a good day here, except for this radio. So I ended the last video kind of having my eyes popped open by the last few tests I was doing on this radio. Yikes. I think I need a new approach. I've been sort of starting at the antenna end on the assumption that if there's something wrong with the radio, it's just one thing and I can find it. Since starting, I've discovered that, of course, the radio is highly modified in certain areas, and that makes it more difficult to sort things out. The last change I made was to solder in this wire, this resistor here, into this spot, which I think is the right spot for it, pretty sure. So I think a new approach would be to start at the other end, to start at the output end of the radio, and start working my way back towards the antenna. And we'll see how far we can get that way. And the way I would do this is not that by listening to things so much, well, yeah, be listening to them coming out of the speaker, hopefully. It's a question of injecting signals, audio signals, into the radio, into the grids of the tubes involved, and seeing what comes out the speaker. It's not a complicated affair. Ooh, famous last words. But most importantly, I now must go and prepare some coffee for this. Okay, let's start with a look at the schematic down at this end. This is where, of course, he has a capacitor running from here to here, a resistor running from here down to this line here. Hopefully that's what he's done. So I could inject a signal into the grid here, and I could inject one into the grid here. This gets a little weird. I could probably inject an audio signal into here. In fact, you know what? Isn't it possible you could inject, no, you can, I was going to say, an audio signal all the way back here and have it come through, but it won't get through these transformers, but it would get through the capacitors here. Of course, it's all set up for audio. Okay, so that's what we'll do. Just go grid, 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 stick a signal in and hear what comes out of the speaker. Very good, very simple. Okay, so I'm getting ready to use this audio generator here, which we will turn on as soon as I remember how to do it. We're set on the B 1000 hertz. So 1000 hertz tone going to come out of here. The level is controlled with this. Very good. The ground lead from this device is right here, connected to this ground that's going to this terminal, going over here, going to this terminal rather. Okay, everything seems good. What I'm going to do, let's practice a bit. I'm going to touch this to the grid of the output tube, that would be here, and then grid of the next tube, which is here, and grid of the third. Just maybe it'll work. There, there, and there. Yeah. Okay, that's the plan. Sounds pretty simple to me. Let's start up the radio. There we go. Very strong and unusual hum coming out of here, and one of these tubes is glowing like a light bulb. What's happened here? Let's just take this off. Could be I'm just a little too excited or something. The tube up above here just glued like crazy. Let me turn down the supply a bit also. Okay, I'm going to try again here. Maybe just that's not going to make much difference. Here we go. So this tube up here is glowing. These tubes do glow. You're really trying to heat. No, it looks the same as the other tube. I think I'm just crazy. You're trying to heat these tubes up to a yellow color, not a red color. So they're actually running hotter. Okay, was this causing something? No. I did turn the supply down quite a bit. Okay, so we have a signal of some level way down here now. Some unknown level. I'm going to turn it right to 0. Touch it to the grid here. So a little bit of static coming out. Okay, I'm going to give it a little bit of tone here. Well, now it's possible there's no signal coming out of my box here, so I need to test that. So we will do it. I'm just going to hook it to a speaker and make sure there's something coming out of it here. Volume 0 right now. Let's go. Okay, so the problem here is I grounded the wrong red, black. How stupid. Man, the man can be pretty stupid at times. Okay, hold on, we'll go back. We'll assume the signal's there. Try this again. I would say no on that. Have I done something stupid again here? Now we're going to make sure the signal's coming out of the my box here because it's intermittent quite often. A little like my brain actually. Okay, here we go. We hear nothing. That's what we want to hear. Okay, now we know it's working. Input level's low. There it is. Coming out of here. It's got intermodulation distortion. This shouldn't do anything here. Okay. You hear the level. I'm going to go back one tube now. Much higher level. Just what we'd expect. Terrible distortion in it though. I'm going to go back one more, but I don't know if it'll come through. Oh yeah. Well, for fun, let's just go and do these. No. So we're not going to get the audio through an RF stage. Audio stages are working. If an audio signal was presented to this grid, it would come out the speaker. So we know all this is good now. Okay, with that proclamation, I think I will go and engage with some coffee. We seem to have sort of come in two directions to this spot of the radio. That's what it seems like. Okay, let's review the situation here. So I put an audio signal in here. Here, of course, these transformers are not in this radio. And I put a signal in over here. And it all came out the speaker. Pretty distorted, but it came out. And so at the same time, I've used a coil at the same time. Earlier time I used a pickup coil to pick up signals coming out of these transformers, and I convinced myself that the signal was proceeding through this tube, through here, through this tube, but not getting beyond here. Right in here something is happening. So we kind of have this coming at us from two directions now. This is the trouble area here. Okay. Now we know that. I guess it's a matter of looking at this component and this component. Grid leak, 2 megohm grid leak, right on the grid of the center tube. Let's find this grid leak resistor. Okay, the middle tube is this one here. So this would be potentially the grid leak resistor, this big wire wound one. There's also a component right here, which I think is a capacitor. I'm not sure. So let's do a couple little tests here. Did it say it did say the resistance on that diagram, didn't it? It said the resistance is 2 megohms. Okay, Mr. 2 megohms. So a wire wound resistor that's 2 megohms, that doesn't go together very well. That's 100K according to that. And this one up here, 5 megohms. Well, you know, that's 2.5 times what it's supposed to be. That's an awful lot higher. .5 megohms instead of 2. Let's look at the circuit again. So we're talking about 5 here instead of 2. Would that silence this radio? I did feed a signal in through here. I fed it right on this point. You know, and in that case, I think even if this were 50 megohms, it wouldn't matter. We would hear the signal come through. If this were shorted, that would be a different matter. Or if it were open, I don't know what it would do. If it were open, this kind of becomes, well, it would should be a ground potential plus whatever signal's making into it. Still curious about how these get biased. I don't see that this is an auto biasing arrangement here. Doesn't look like it to me. So I don't quite understand that. I guess I could bridge this with another large resistor and get it close to 2 megs, see if it makes a difference. What about this capacitor? Let's find this capacitor here. Okay. Find the capacitor. Couple obvious ones there. So the capacitor's connection is right to the top of what is the grid leak. So top. So this capacitor is connected right here. This is connected to the plate. Just looking over to make sure the power is not on while I'm sticking my finger in here. And so what's this one doing? This one's going from the grid. Oh yeah, this is the plate. Yeah, I'm not looking at this right. This is the grid here. This will be the grid leak. What am I doing here? I'm all confused, aren't I? Don't worry, I'll get unconfused in a moment. Yeah. So what's that one? We'll look again at the schematic. So yeah, I can bridge this or just replace it. It's just nothing special about this, is it? Why is it in this fancy, feels almost like glass tube? Why would they do that? Because you can kind of see the end of the resistor there sticking out. Bit of an odd guy there, sorry. Get a little involved with things at times. I think the smartest move, just replace it and put a 2 meg resistor in there. Okay. Okay, so some time ago I stopped including in these videos the actual desoldering and resoldering of stuff because of the time involved in doing that. But in this case, I think I'm gonna This is a strange looking thing, that's for sure. I don't think it's a resistor with a tube slid over the top. I think it's more, I don't know what it is. Let's put it on the tester here. Yeah, still reads high, not as high. Okay, and my new resistor's right here, which we might as well just test because I have it right here with my fingers on it. What? Something not right here. You can see the value of it, red, black, green. And I tested it earlier, and it was almost exactly 2. Oh boy, yeah, the battery's gone low. This is that's not good. What's with my meter here? The Allen meter. It has a funny symbol on it here. I don't know what it means. Try another scale. Something's happened. Funny, when you're doing this work, if it's not one thing, it's something else. If it's not the device you're testing, it's the devices you're testing it with. What's happening here? What is happening? I tested this resistor with this other meter, and it was 2 megohms. Oh my gosh. Okay, small aside, I gotta find more meters to test it with. Well, I'm going on the assumption now that something's gone wrong with this. What could go wrong with it? So I'll get another one out of a package with the label right on it, 2 megohms. red, black, green, gold. These are gold. These are golden resistors. Not vintage in any way. I don't even know what to say. Some effect of the sun today that's throwing everything off. This has got the dust on it from the great fire extinguisher accident that happened. If you don't know what I'm talking about, a fire while my house had no electricity. And just when my wife and I were here, because we were hanging out in a hotel room for a few days, but we'd come back here. And we're just standing in our house, and all of a sudden a fire extinguisher just spontaneously released and emptied itself right here in my shop. Holy smokes. Filled our house with powder. And that was what was on here. I haven't cleaned it all away yet. What is going on here? What? Like, it's not my fingers. Can't be my fingers, can it? Come on. My fingers were doing that? This just all over the map. That's about all I have to say. Just grab any old resistor. So 33 with a, looks like orange brown or orange black. 33 or 330. $30 instead of 33. I think that's okay though. I don't understand this. $325. What's going on? 325. Maybe I read this other one wrong. Yeah, I think I did. It's 303. 303 on this one. $325 on that one. So that's probably a brown. So it's probably 330. 330. So everything fine. Good. Somebody help me. I'm a mental basket case here. Green is 5. So you have 2, 0, 5 more zeros after it. That's 2 with 6 zeros. That's 2 with 3 sets of 3. That's 2 million. That's 2 million. There's no two ways about it. It's 2 million. Man, I'm going to take these resistors. I'm not just going to drink the coffee. I'm going to dip the resistors in the coffee for their own sake. Happening to these resistors. These are high quality resistors. These should not. I have resistors that have the value written on them to 3 decimal places, like 127.285 ohms. I have a bunch of those. What's the matter with me? Something is wrong with me today. It's my fingers, for crying out loud. But I didn't have my fingers on it before. fingers all this time. Oh man. You know, I've been measuring resistors since I was like 10 years old. Oh my gosh, that was terrible. Okay, the resistor's in. Right there. Let's give them a try. We're going to try this on the antenna and take a shot. We're taking a shot at it here. I would not put any money down on this working. But let's give it a go. The weather today is fantastic. Sunny, and it's going up to it's going up to 13 degrees. So I'd much rather be outside getting some work done. Okay. Everybody ready? What about this? Okay, now we're ready. Okay, radio, what do you do? These are turned almost full. Hum came out of there right away. So these radios go into operation almost immediately, the filament type. And what am I hoping to hear? It's a real long shot. A radio playing. Now this one's tuned correctly, number 70. Correctly being tuned for 590. No, we're not going to hear anything here. We're crying out loud. Okay, but I had to do that just for the satisfaction of it, or lack of satisfaction. Okay, no, that's it for today. Tomorrow we'll just carry on, just keep nibbling away at it. Sooner or later I'm going to find it, I'm sure. Thanks a lot for watching, and I hope you have a great day too. See ya.